Hey there! Today I want to talk to you about nuclear power. In this video, we'll get a broad overview of a generic plant, which will demonstrate how we yield tremendous energy output from just neutrons. Once we have this basic level of understanding, we'll start our dive into what's happening at the atomic level. Okay, great, let's see what's happening in a nuclear power plant. So it all starts with the reactor. For right now, all you need to understand about the reactor is that it's a place where atoms are decaying in a process known as fission, releasing energy. The energy is released partially in the form of heat. Water, known as reactor coolant, absorbs the heat and delivers it for use in the steam generator. Now, by removing heat and transporting it to the steam generator, the reactor coolant is keeping the reactor at an acceptable temperature and providing steam generator with the energy required to produce steam. Now, the coolant exiting the reactor is actually quite hot, several hundred degrees Celsius, in fact. The steam generator provides for the exchange of heat from the coolant to the water in the steam generator. Now, it's important to note that the coolant and the water in the steam generator never come to contact. That would be quite bad, as the coolant contains some sources of radiation. We want to contain, keyword there, the coolant to as restrictive of a space as possible to minimize the chance of spreading contamination. So, depending on plant design, we may run the hot coolant through the steam generator here in very thin piping. So the cooler water in the steam generator is on the other side of that very thin piping, absorbing the heat. That water now heats up and becomes steam. Once again, at no point does the reactor coolant come in direct contact with the water that ultimately becomes steam. The steam generator is just acting as a heat exchanger, transferring heat from the reactor coolant, which is contained in the primary system. The primary system here is the red piping. The steam generator is transferring heat from that primary system to feed water, which is contained in the secondary system. Secondary system is, as you can see, the blue piping. So for this reason, sometimes we just call reactor coolant, we just call it primary. When we say secondary system, we're referring to everything else. So let's continue following the flow of steam in the secondary system. We have steam, so let's put it to work. A turbine is going to catch the steam and translate this energy from the steam into rotational motion. The turbine will spin and rotate a coil of wire here in the generator through a magnetic field, which will generate electricity. And that electricity will make its way to your home and to your devices. Okay, so now the steam has done its work. Now, wouldn't it be great to have that steam return to its water form and be used again? How would you do that? Well, just think. We can accomplish a change in phase by varying pressure or temperature. So how do you think we're going to get steam back into water? We're going to cool it down. So we're going to change temperature. So we'll do that by running the steam through a kind of another heat exchanger that we call a condenser. And the condenser, as you may guess, condenses steam into water. It's fueled by this independent source of water here, which is often just off-site water, either seawater or just fresh water, depending on where the plant is installed. So it's cooled down and it condenses into steam. And now a feed pump moves that newly transformed water, moves it back into the steam generator. Okay, now let's return to the primary. The coolant is now exiting the steam generator and, having transferred some of its heat to make steam, has cooled down. This reactor coolant pump here will now drive the coolant back into the core, and the process repeats. Now, there is one key part of the primary that I haven't mentioned yet, and that's the pressurizer. In a pressurized water reactor, we want the primary coolant to remain in a liquid phase. But how can it remain in liquid phase if the coolant's over 300 degrees Celsius, you might ask? As I mentioned earlier, we can either vary temperature or pressure to affect a change in phase. Well, since we know the liquid is very hot, we know we're going to have to do something with pressure to keep it a liquid. So we need to raise pressure we need to raise pressure to keep reactor coolant a liquid. And that's what the pressurizer does. Through a system of electric heaters and spray, we can control pressure in the pressurizer. And if we control pressure in the pressurizer, we can impact and control the pressure in the entire primary system here. Okay, that's just a brief sketch of what happens in a pressurized water reactor plant. Now let's move on and see what's happening in the reactor.